Mass spectrometry. This is question paper 1, and this is the question paper itself. We do have the marking scheme, but we'll open it up on need. This is from Save My Exams. Thanks to them. Thanks to you as well. Getting started with question number 1. Okay. I hope it still is readable.
Yes, sir. For 24, it should be 79, 25 के लिए 10 and 26 के लिए 11.
79, 25, 10, and 11. All right. Good enough. Moving on.
Use your values in part 1 to calculate relative atomic mass of magnesium to 2 decimal places. So 24 multiplied by 79 plus 25 multiplied by 10 multiplied by 11 divided by 100. 24.32.
24.32. Perfect. Moving on. This is definitely not related to mass spectrometry, so let's skip it. NMR, skip it. I'm only going to ask you questions from mass spectrometry, so if there is anything related to some other stuff, we won't be doing it. Okay, C part. You can definitely do C on your own.
When an isomer of P is heated with concentrated H2SO4, it forms a new compound Q. This new compound Q reacts with bromine to give a dibromide, R. A mass spectrum was obtained of R. The ratio of the heights of M and M plus 1 peaks was 9.3 and 0.5. Show that there are 5 carbon atoms present in one molecule of R.
I hope you remember the formula that is present in the book related to this part.
Actually, I don't remember the formula.
Come on, there was something related to N. N is the number of carbon atoms, 100, 1.1,
1.1
percentages,
yes.
something like that. There were 2 factors in there. It should be easy. Does that ring a bell?
Yes, yes.
Good.
100, 1.1, 9. 4.88, approximately 5.
All right, makes sense. Part 2.
Predict the ratio of the heights of the M and M plus 2 and M plus 4 peaks as a result of the 2 bromine atoms in the dibromide. R. Show your working. ये कैसे करना है?
इससे भी related material है book में. Do you have the book in front of you?
Yes,
Better
sir.
if you do. Then there is the
Yes,
part
I do.
which tells us that how are we supposed to solve it in case of a single halogen atom, maybe a single chlorine atom or a single bromine atom. And then there is another part which tells us the height of the peaks if there are two bromine atoms or two chlorine atoms, and they give us the idea how that's possible. Actually, the answer to this part is already written in the book, but they do give you a mathematical idea how to calculate it as well. I hope that helps.
Placed on 1:2:1.
1:2:1. That is correct, but you still need to uh, prove it, show your
Mm,
working, which means there is a simple point that they are trying to ask of you.
mm, mm. Two bromine atoms.
Do you remember how we were able to land at the ratios of 1:2:1? Or what was the major reason behind it?
Mm, no.
Come on. It has something to do with the relative abundance of different bromine isotopes. Do you remember that?
79 and 81.
These are the masses of those isotopes, not the relative abundance in percentage.
50/50. Mm,
Do you have the book in front of you?
yes.
Then there is a heading by the name using M+2 plus and M+4 peaks.
Yes.
And right below that heading, we have a simple table that tells us if we have two isotopes of bromine, both would have the approximate percentage of what?
Yes. 50/50.
50-50. And then right after that, it tells us about the compounds that contain a single halogen, maybe a single fluorine or a single bromine atom. If you keep moving, then there will be a topic that tells us if there are two chlorine or two bromine atoms per molecule. By the end of that topic, two chlorine or two bromine atoms in a molecule, the last lines tell us that if the ratio between these uh, bromine atoms, because of the isotopes, is going to be same 50-50%, the chances are 1:1. So if you go to work out M ratio, M+2 ratio, M+4, the height ratio turns out to be 1:2:1. So
Yes,
that's
sir.
what you are supposed to show that as working. What you're supposed to do over here, let me clarify. What you're supposed to do over here is that you're supposed to tell them that bromine 79 and bromine 81 actually has a ratio of 50-50%. 50% this, 50% this. So basically, we can say it has a ratio of 1:1. Now, when we are supposed to work out m into m plus 2 into m plus, sorry, this is 2, m plus 4, then this 1:1, and it also works as 1:1. So this whole thing become 1:2:1, and that's what your answer is supposed to be. Make sense?
All right, sir. Yes, sir.
याद है मैंने थोड़ा सा मैथ का स्टेप बताया this is multiply this and this is multiply these two are added then we get our answer something like that because
Mm-hmm. Yes,
bromine
sir.
was very easy 1:1:1:1 नहीं लिखा होता कोई फर्क नहीं पड़ता but when we talk about chlorine there was 3:1 and I told you how we are able to get that 9:6:1 answer.
Yes, sir.
Good, good. So Moving on. Molecular formula of R is difficult since you don't know about that stuff, so it is going to be difficult. You don't know what P was or Q was or R was, so let's skip this one. Okay. Okay. 3 part A. Remember, we are only going to do the parts that are related to mass spectrometry and forget the rest of the analytical technique, whatever that is.
सर ये analytical technique included नहीं है?
Means NMR spectroscopy and stuff like that is not included, but mass spectrometry is included. What they've done is that out of all analytical techniques, they have picked mass spectroscopy from A2 and they have now made it a part of AS. So that's why we only do a mass spectrometry completely as a part of AS and we leave the rest for A2, NMR and etc. etc.
Okay, sir. Okay, sir. So the combination of mass spectroscopy and NMR and MR spectroscopy provides a powerful method of analysis for organic compounds. The mass spectrum of a compound G contains M and M+1 peaks in the ratio of their heights of 74:2.5. Use this data to calculate the number of carbon atoms present in G. Show your working.
Again, the same formula. This should be easy, right?
3.07. So 3.
3. Very good. Okay. Moving on, let's skip the NMR parts. All of them. Next. Question number 4. Part A.
T is a saturated alcohol. It was analyzed by mass spectroscopy and NMR spectroscopy. In the mass spectrum, the molecular ion peak M was at an M per E value of 74, and the ratio of the heights of the M and M+1 peak was 20.4 and 0.9. Use the ratio of the heights of the M and M+1 peaks to calculate the number of carbon atoms in a molecule of T. Four.
Good. Moving on.
What is the molecular formula of T?
This should be
Molecular
easy.
formula. 1 second. Molecular ion peak M was at an M. Sir, M per E क्या था?
Simple MR. It's
MR,
equal
okay.
to the MR value, but since we are
74.
talking about a compound, we're talking about it
Not
in
the
this way.
carbon
Remember,
atoms.
this can be MR of them having a specific isotope and not the general MR that we consider every time. It can be a little tricky for M over E values in mass spectrometry.
Okay.
So if the MR is 74 and you already know the number of carbon atoms are 4,
Carbon atoms,
what,
yes.
so what molecular formula does come to your mind? And don't forget, it was a saturated alcohol. That's the very first line they started off with. Which means alkanol. It can't be an alkenol or alkynol. It can't be anything else really. Come on,
C4H9OH.
C4H9OH. Good. They are asking for a molecular formula, not a structural formula.
So C4H10O.
C4H10O. Perfect. Now you've done it right. Okay, let's skip the NMR part, all of it. Moving on. Yes, number 5.
The techniques of mass spectrometry and NMR spectroscopy are useful in determining the structures of organic compounds. The three peaks of highest mass in the mass spectrum of organic compound L correspond to masses of 142, 143, and 144. The ratio of the heights of the M and M plus 1 peaks is 43.3 and 3.35, and the ratio of heights of the M and M plus 2 peaks is 43.3 and 14.1. Use the data to calculate the number of carbon atoms present in L.
This is a good one.
Okay. Seven.
All right. Which one did you do? 43.3 and 3.35?
Yes.
And you use the same 100 over 1.1 formula, right?
Yes.
Good. 7. I haven't calculated it, so I'm assuming what you've done is right. Okay, moving on. Part 2.
Explain what element is indicated by the M plus 2 peak. What element is indicated?
Now, this time we're not taking a ratio between M, M plus 2, M plus 4. We're just talking about M and M plus 2, which means we're talking about one halogen atom per molecule. But which halogen atom is it? Is it chlorine? Is it bromine? How would we know? And since I've answered this question already in my previous explanation, this should come easy to you.
Chlorine.
Very good. And how did you come up with that idea?
The ratio.
What about the ratio?
9 ratio 14 ratio no,
What?
9 ratio 6 ratio 1. Sorry.
We don't have two atoms. Don't go for that. It's different. We only have a single atom. Single atom ratios are different. Those are the ratios 1 ratio 2 ratio 1 and 9 ratio 6 ratio 1. Those are the ratios for two atoms per molecule. This one only has one halogen atom in this molecule. So that is chlorine. You're right with that. Okay. Now let's not waste time doing it quickly. We know for BR, the ratio between 79 and 81 is 50 and 50. So the height of the peak, M and M plus 2 peak, the ratio should be same, exactly the same. If this is
Oh,
43,
sir.
this should also be
75 ratio
43.
25.
Right, this is 3 ratio 1 or 75 ratio 25.
Yes.
Means the same thing. Let's not go for a difficult answer. 3 ratio 1 is a perfectly good explanation because if you multiply 14.1 into 3, the answer you'll get is 43.3.
All right, sir.
Okay, so moving on.
Yes.
We're done with this. Let's skip NMR. Okay, B part. B
The molecular
one
form.
only. B2 is something that is out, of course.
The molecular formula C3H6 represents the compounds propene and cyclopropane. Suggest one difference in the fragmentation patterns of the mass spectra of these compounds.
Now, this is a little bit difficult. So, since not also a part of your book directly, so I'm going to go ahead and what was the question number? This was question number 7 or 6. Let's see. Let's take a look. This is question number 5. So we are doing question number 5 and we're talking about part B. So this is 4. This one's 5. Part B. We expect propene to have a CH3 peak or a peak at Me15. Understandable, it means the same thing. Or cyclopropane would have fewer peaks. So these are the two possible answers, and you can pick either one of them. Make sense?
All right, sir. Yes.
Okay. So this C single bond C bond might break. Double bond will not break in case of propene. So the chances are that it fragments over here. Here we'll get CH3 out of it. If we get CH3 out of it, we'll get a 15 peak. Now, in this case, if we break any bond, all right, it would be converted into a single chain portion,
Yes,
which
sir.
would have radical and positive charges on one end and the other. It would you have to break two bonds in order to break it upon into two different pieces. While in propene, breaking it apart into two different pieces is very easy. Does that make sense? So talking about
Yes, sir.
propene CH3 as a radical is a very good difference that you can state over here about CH3 or the M over E value being 15. It means the same thing. Okay,
Yes,
I
sir.
hope you get the point. Now, since that wasn't that clearly explained in the book, that's why I had to go through it. Keep that in mind. Okay. Moving on, NMR, NMR, yeah, D.
Compound P is an alcohol that can be converted into compound Q in the following reaction sequence. Spectral analysis of P and Q were carried out. The mass spectrum of P shows an M and M plus 1 peak ratio of 4.5 and 0.15. Calculate the number of carbon atoms in P. 100 into 0.15. 3.
3, all right. Moving on, let's see. No, that is NMR, NMR, and there we go. That's the end of this one. So let's close this one down and let's try another one. So this is the question paper. This is the mass spectrometry second question paper. Let's try this one. Let me zoom it out a little bit so it's easier to move. Okay, you can do one half of part one, part A1. I mean, they have already given you in the A part the idea about mass spectrum. So let's try and solve that part alone.
Okay,
I
sir.
mean, trying to find out number of carbon atoms.
Okay. Although the chemical reactions of compounds remain important pointers to the functional groups, instrumental techniques such as mass spectrometry and NMR spectroscopy are increasingly used to determine molecular structures. Compound J was analyzed using these two techniques with the following results. The mass spectrum showed that the M peak was at M per E 86. The ratio of heights of the M and M plus 1 peaks was 23.5 and 1.3. NMR spectrum is shown below. Use the data to determine the number of carbon and hydrogen atoms present in J. Okay. Five.
All right. Keep that stuff in mind. We can't really find out hydrogen atoms because for that purpose we have the NMR spectrum. Okay. If we knew about hydrogen, we would definitely be able to. I'm going to pause sharing for a while.
Okay, sir.
Okay, can you see the sharing again? The same paper?
Yes, sir.
What's your answer to number of carbon atoms? Check that again. Can you tell me, along with the exact decimals, what answer you're planning at?
1 second, sir. 1 plus 100 into 1.3 divided by 1.1 into 23.5.
Right.
5.03.
Uh-huh. 5.03.
Yeah.
I don't know, but when I look at 0.22, yeah, 5. 5, sorry. This is question number 2, right? Yeah, this is question number 2. My bad. I was considering that might be question number 1. So I'm going to resume sharing. And let me tell you that there are 10 hydrogen atoms. Okay.
Okay, sir.
Now try and find the part 2. Let's move on to part 2.
Propane. No, sorry, propene.
Wait, what?
The other. Wait, use the information given above and your answer to part 1 to identify the other element present in J. Other element? Oh, okay. 1 second. Plus 570. Sir, can you scroll a bit up?
Okay, you have all the information above, and
7086.
there are 10 hydrogen atoms. So 5 carbon atoms, 10
Oxygen?
hydrogen atoms. How many?
1.
1. 5 carbon means 60, and then there is 70, 86 means 1 oxygen atom. Good. Now, can you come to, you can't really come up with the structure. Can you tell me the molecular formula?
C5H10O.
Let's not talk about the structure because you can't do the structure right now since you're not familiar with NMR. Okay, get this one, NMR X-ray, NMR again. We've done a question like this, so Let's try and do this one. This one's different. We scroll a little bit down. Okay.
A saturated molecule of formula CXHYNO was subjected to analysis by mass spectrometry and NMR spectroscopy in the mass spectrum of the compound. The M peak was at M per E 73, and the ratio of the heights of the M and M+1 peak was 78 ratio 1.7. Use the data from the mass spectrum, determine the values of X and Y in the formula of the compound. Okay.
Now, NMR is not going to help you anymore with number of hydrogen atoms, since you can do that with simply the formula and the masses you're given with M/E values.
Plus nitrogen is 14.
Right.
72. C3H7NO.
X is equal to 3 and Y is equal to 7 for now.
Yes.
Right. Okay. Can't really talk about the structure. We know about the NMR. Electrophoresis is not something we've done. This goes with the previous question. You won't be able to do it. And this is the end of this one. So let's find this one up too. Is the marking scheme question paper. Let's solve the third one. Okay, let's try and solve C.
The mass spectrum shown was obtained from a compound of formula CpHqX, where X represents a halogen atom. Deduce the identity of X giving a reason. Hmm? Mm. Mm. It's not bromine. It can be chlorine. So most probably chlorine because of the peaks.
Okay. And how did you come up with this specific answer?
If we see the first peak, it is approximately somewhere, I think, 20, 27 or 25. And then peak R is 90 something, 90, 98. And then the third peak is 8.
It
So
what?
just 8.
And which peak is that? Which peak are you
Third
calling
one,
as?
the last one, is approximately 8 or 9.
come you're calling it third? Which peak are you calling as the third peak? There are so many peaks. Can you point one out?
Yes.
Or can you say it out loud so that I get the idea which peak are you calling as the
Yes.
third peak?
I'm trying to annotate, but it's not
You
working.
can tell me out loud, that's fine if you're not able to annotate.
The 120, 123 something.
Oh, okay, you're talking about that one. The one far ahead to the
122.
right.
Yeah.
Is there anything to do with the whole thing?
Mm, we'll just take the ratios. 1 ratio approximately 6 and 9. So chlorine.
Okay, let's see, let's check that out. Is this question number 1? Yes, it is. But the ideas in the starting lines was really understandable, moving or jumping towards the first, second, and third peak makes the whole idea a little bit difficult for me to understand. So C1, excess bromine, Mn plus 2 peaks are almost of the same height. Okay. And apart from that, 9, 1.1, you were right. So it gives us the idea of 3, C3H7Br. All right, moving on.
Sir, I don't get the part bromine part.
You were right about this one. The Mn plus 2 peak are almost equal.
So it's bromine.
Yes, it is bromine.
Okay.
Okay, the jump from this peak, which has been mentioned, R, which is probably the molecular peak without bromine, is this one, and the other two peaks at this is probably 122 and one is 124. That is M and M plus 2 peaks, and yeah, they have the same height. Because of this same height, it's understandable. For this one, this is probably C3H7 because this is at 43. Again, since we recently done a question with 43, it should make sense.
Mm-hmm. Yes, sir. Part 2.
Yes, part 2.
If the relative heights of the m and m plus 1 peaks are 9 and 0.3 respectively, calculate the value of P, use this value and the m per E value of the molecular ion to calculate the value of Q, and hence the molecular formula of the compound share working. Um, Carbon atoms are 3.
Carbon is 3, all right. Since you need to see it again, okay, there you go. You can see the whole thing.
Okay. H. Bromine is 79.9, right, sir?
Yes, approximately 80.
And they said the molecular MR कितनी है? It's not given.
M over E value is given.
M over E value is 124.
No, beta, that is M plus 2 value. So M over E is the previous one. You're not supposed to pick out of these two same values. You're not supposed to pick the one on your right. You're supposed to pick the one on your left, and that is 122 beta.
122.
That's the molecular ion peak.
So yeah, C3H6Br. So P is 3 and Q is 6.
Okay, in this case, remember, since we are doing mass spectrometry, this one has bromine 79, this one has bromine 81. So you're not supposed to take it as 79.9 in this case, or 80. You're not supposed to take the relative atomic mass, you're supposed to take the isotope you're working with. The one on your left has the 79 isotope of bromine. The one on your right has 81 isotope of bromine. So since you're working with the one with the left, I hope you've taken the value as 79. If not, if you have taken
Yes,
it
sir.
as 80, take it as 79 and repeat the answer again.
C3H7Br. So P is 3 and
C3H7Br.
Q is 7.
Good, good. Okay, suggest a formula for the ion responsible for the peak labeled as R.
M.
Sorry?
M plus sign. Molecular
Suggest
ion.
a formula. How many
Or
carbon,
formula.
hydrogen atoms, or what else it would have. Of course, it's not going to have bromine. Bromine is too big for this value. So how many carbon and hydrogen atoms would it have?
Mm-hmm. 1, 2, 3.
This is 43.
43. So C. We just did this question. C3H.
So out of C3H7Br, what would be the formula of the peak labeled as R?
C3H7.
Perfect. Okay. D.
In the fragmentation of alcohols which occurs in a mass spectrometer, small stable neutral molecules are sometimes produced. Suggest the identity of two such molecules, each with an MR less than 30. CH3? No. They said alcohols.
Small stable neutral molecules. Keep that in mind.
Small stable neutral molecules. What do they mean by neutral?
Neutral means they're not going to be free radicals, they're not going to be positively charged cations, they're only going to be neutral molecules. No charge on them.
Okay.
So make sure whatever you're making does not have charge on it. Because, for example, in the previous one, the formula of the ion was C3H7. And since we have separated Br or probably fragmented it, it is C3H7 positive. But here we are supposed to answer in with two molecules that don't have a plus or a negative charge, positive or a negative charge. Plus, make sure it's a neutral molecule and not a free radical either. Remember, it is an alcohol.
Steam plus CHO.
Is it a neutral and a stable molecule? CHO.
No.
No, it isn't, because the number of bonds the carbon is supposed to have are not complete. Okay. Since we don't have enough time, so I am going to take you to the answers. Okay. Anything from hydrogen gas, water, carbon monoxide, ethene, ethane, or methane would be good. Anything that
But
you
didn't
can
they say
make out
alcohol?
of Sorry?
Didn't they say alcohol? So
Yes, they did.
C2H4 कैसे?
That's a fragmentation. It's a broken apart from an alcohol.
Oh,
So if you
alright.
break down an
Okay.
alcohol, and the broken part should be smaller than the MR of 30, right? So this is less than 30, this is less than 30, less than 30, the list goes on.
Okay, sir.
Actually, you're trying to break an alcohol. What he's trying to tell you that your formulas can have either C's or H's or O's. That's what he means from alcohol. He's not saying that the whole identity of the alcohol would remain the same. Of course, that's not possible. If we're going to fragment it, it's going to break down into smaller pieces. If that happens, we need something that has a mass less than 30 and is a smaller fragment out of an alcohol. I hope that makes sense, right?
Yes, sir.
Good.
Yes, sir.
Moving on. We're not over here. See what we have in the next question. No. Okay, C part.
A combination of mass spectrometry and NMR spectroscopy is often enough to determine the structure of a simple organic compound. The organic compound N produced a mass spectrum in which the ratio of the M and M plus 1 peaks was 5.90.2 and which had an M plus 2 peak of similar height to the M peak. Calculate how many carbon atoms present in one molecule. 1.2, 3.08, so 3. Deduce which element other than carbon and hydrogen is present in N. Carbon and hydrogen. हाइड्रोजन की पीक कैसे पता चली हमें?
No, we're not talking about hydrogen peak.
But they
He's
didn't even give
asking
us the
which
MR.
third element is present other than carbon and hydrogen in N.
But we don't have the MR.
You don't need the MR. He gives you
Oh,
another
wait,
hint.
wait, 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 wait. Which had an M plus 2 peak similar. Bromine.
Bromine, very good. Because the height of the M and M plus 2 peak was same. Now, moving on, number 3.
Explain how many atoms of this element are present in one molecule of M. How many atoms of this element are present in one molecule? I think
Sim-
one.
1, very good. Why do you think 1 is correct and not 2?
Because they didn't mention any M plus 4 peaks.
Perfect, because they didn't mention any N plus 4 peak. If there were 2 atoms of bromine, there must be an M plus 4 peak. Okay, this is not it. Mhm. Okay, part C.
Compounds used as pesticides may contain bromine or chlorine. What would be the difference in the ratio of the M plus 2 peaks if the pesticide contained one chlorine rather than one bromine atom? M and M plus 2 peaks in chlorine. 75 ratio 25.
Simplify it.
So
Please
like
don't use bigger
3
numbers.
ratio 1.
3
3 ratio
ratio
1.
1. That is right. That is right. Part 2.
If a given pesticide contains 2 chlorine atoms per molecule, deduce the relative heights of the M plus 2 peaks and M plus 4 peaks. 9 ratio 6 ratio 1.
Very good. How are you going to work it out? The answer is correct, but this is a 3-mark question, which means 1 mark is for part 1. There are 2 marks for this part. How are you going to show a little bit of
Um,
working to get to 9 ratio 6 ratio 1? Again, the same thing as I've explained
75.
earlier.
75 ratio 25 gives us 3 ratio 1. लेकिन
Right. So what you're going to do is that you're going to go with M and M plus 2, and then you're going to go with M plus 4. Remember, this is something mathematical, so you're supposed to do it like this. So 3:1, and then again write 3:1, and then write it like this, 9:6:1. Remember, I told you we'll multiply these two. This comes as 9. We multiply this and this, this and this comes 3. 3 plus 3 is equal to 6. And it's 1 into 1 is equal to 1. So that's how it works in math. Okay?
Sir, can you
But if
explain
you write this
6?
whole thing, they are going to get the point.
Sir, how did we get 6?
Okay, this into this, right? And this into this.
Yes.
The answers are mentioned like this,
Okay.
right? Usually teachers
Yes.
explain it like this into this. Okay, now we switch the positions. This is multiplied by this, and this is multiplied by this, and the answer are added. So it's 3 into 1, 3, plus 3 into 1, 3. So 3 plus 3 is equal to 6.
Oh, all right. Okay, sir.
So we also multiply the numbers for the inner part. So since there are two different multiplications, we add them up for the inner part. That's how we were able to do it with 1:1 and then 1:1 again. So since 1 and 1 is 1, 1 and 1 is 1, but 1 and 1 is 1 plus 1 and 1 is 1. So the inner part was 2, right?
Yes, sir.
I hope now you understand both of these. But if you just write the, you can actually get the whole mark. They would understand that you understand the process even if you don't. Okay.
Yes,
With
sir.
pure memorization, but sometimes biology students are incapable of doing that at that point, so we don't push them towards it. Though they should be, if done IGCSE, shouldn't be a problem. Okay, part C.
At one time, bromoethane was widely used to control insect pests in agricultural crops and timber. It is now known to break down in the stratosphere and contribute to the destruction of the ozone layer. Samples can be screened for traces of bromoethane by subjecting them to mass spectrometry, which peaks would show the presence of bromine in the compound. M and M plus 2 peak.
Good. Part 2.
How could you tell by studying the M and M plus 2 peaks that the compound contained bromine rather than chlorine? Same height of M and M plus 2 peaks rather than 3:1. Like 1
Right,
ratio 1 rather than 3:1.
right. So moving on. B.
In a mass spectrometer, some hydrogen chloride molecules will split into atoms. The mass spectrum of HCl is given. Chlorine has two isotopes. The hydrogen involved here is the isotope H11 only. Which particle is responsible for the peak at mass 35? Which particle is responsible? Um, M plus 1 peak?
No. Which particle?
Which
You need to
particle?
name the particle. Whether that's HCl, HCl as a whole, whatever that is. It can be an atom, it can be an ion, it can be a free radical, it can be a molecular ion, it can be anything.
Cl, Cl negative?
Cl35.
Yes, sorry, Cl35.
The isotope, the 35 isotope of chlorine, is what is responsible for the peak at mass 35. Now, what would be responsible for part 2 at mass 38?
38. Free radical
And
of
don't
chlorine?
write
No.
negatives. This is not chloride ions, right?
Yes.
Remember, usually what we have in mass spectrum are either the positive ions or the free radicals, not the negative ions.
Cl positive?
No, Cl
Radical?
has only two isotopes. One is 35, other is 37. How come we have 38?
It's the radical.
Radical means it has unpaired electron. An unpaired electron cannot weigh like a whole nucleus. Not possible. Think again.
HCl.
Correct, but not complete. Incompletely correct.
HCl 30. HCl radical. H radical Cl.
No. Forget the radicals and the positive ions. Just talk about the atoms or their isotopes. Remember, this is mass
HCl
spectrum.
38.
Okay, now let me clarify since you're simply making wild guesses. This is because of Cl35. This is 36, and this is because of HCl, but HCl has 35 isotopes. This is because of Cl37 alone. There is no hydrogen. Probably the bonds have been broken. And this is because of, again, HCl, but this time the Cl is 37. So 1 plus 37 is equal to 38. So this is Cl35, and this is
Oh,
HCl, in which Cl is 37. Make sense?
all right. Yes, sir.
This is more about the atoms or this specific isotopes than it is about the positive charges or the free radicals. Okay.
Yes, sir.
And finally, let's finish it up because these are the last questions. Part C.
Use the relative heights of the peaks to determine the proportions of the two isotopes of chlorine. Explain simply how you obtain your answer. Relative heights of the peaks to determine the proportions of two isotopes of mm, the HCl peak is molecular peak, and the 35 peak is M plus 1 peak.
Do you actually even know what you're saying? Okay, let me do that again. This is Cl35. This is HCl with Cl35. This is Cl37. And this is HCl with Cl37. Now, you need to work the relative heights of the two isotopes of chlorine and get your answer.
Oh,
You can either work it with these two isotopes, or you can
yes.
either work it with these
So,
two isotopes or their relative heights, and you can get your answer, right? Do you want me to
yes.
scroll up, or are you going to work with this and this?
Just the two peaks.
Okay, because you can
35
work the
and
other two peaks as
37.
well.
Mm, do we need to mention the ratio?
That is what you're going to get as an answer. But how would you, what processing or what working would you do to get that ratio? I understand you have memorized the ratio and you know perfectly well that 35 and 37 are going to end up in the ratio of 3:1. But what working
Yes.
are you going to do that your answer comes as 3:1?
75. 75 ratio 25.
No, that's not it.
No,
Look
that's
at the
for the
graph.
HCl.
Solve it from the graph.
35, no, 30.
Okay, I'm gonna use some other color. I'm gonna use straight lines.
30,
This is this. This is this.
30 and 10.
Take the ratios 30 and
30 and
10.
10.
So you'll simply wind up at 3:1. So it's pretty
Yeah.
simple to work with it. You can write Cl35, you can write Cl37, and because the answers of relative abundance are 30 and 10, you end up with 3:1, and that's what you prove for 2 marks.
Mm-hmm. Okay.
Okay, now part D. And this should be really easy because this is something we've done back in IGCSE, not in AS.
Use the answer to C to explain why chlorine has a relative atomic mass of 35.5. 75. 1 second. 30 into 35 plus Um, मुझे याद नहीं आ रहा.
याद तो आपको ठीक है, लेकिन आप नीचे का नंबर 100 रख रहे होंगे. That can't really be 100.
Yes, sir.
Think again. This can't be 100. You're not considering 100 atoms over here. Keep that in mind.
Mm-hmm.
Remember, it works like an average. Whatever you multiply it with are probably the number of atoms you're going to divide it with too, after the sum, of course.
Divided by
What numbers are
2.
you multiplying? Go ahead and tell me the numbers out loud.
35 into
35 into? Are you there?
Yes.
So 35 into?
35 in 1 second. 35 into 30 and 37 into 10.
So 30 plus 10 is equal to?
30 plus 10, 40.
So why are you dividing it by
Oh.
100 and why not 40? You're taking 40 atoms in
Oh.
total and you're dividing it by 100. You haven't even considered 100 atoms. The 100 was there because
Yeah.
you were taking 75 and plus 25 atoms in total. Divide it by 40. Then tell me what your answer is. Is it what's written in the question right here or a different
Yes.
number?
Yes. Yes. 35.5.
Okay, this one is a little tricky as a question. If you're taking multiplying 35 by 30 and you're multiplying 37 by 10, remember to divide it by 40. But if you're not using these ratios, instead you are using these 35 multiplied by 3 plus 37 multiplied by 1, that remember you're supposed to divide it by 4. And they've said to use the answer. So that it's better if you use the second one, not these. This is not your answer.
Okay, sir.
The answer was 3:1.
Okay.
Okay.
All right,
So
sir.
remember, this is the sum that we take as a dividing number. 3 plus 1 is equal to 4. Or here in this case, 30 plus 10 is equal to 40. It's not that you every time divide it by 100. It's only in the case if you're considering 100 atoms.
Yes, sir.
Are we good?
Yep.
So far, we are done with the whole theory. Next sitting, we're going to cater MCQs. Any questions before I wind up the call?
No, sir. No, sir.
Allah Hafiz, beta.
Allah Hafiz, sir.